All right, ladies and gentlemen, in this video, we are opening up our discussion on inverse functions. The goals are how to find inverse functions informally and verify two functions are inverses. We're going to graph to determine if a function has an inverse. We're going to use what we call the horizontal line test to determine if a function is one-to-one, and then we're also going to find the inverses functions algebraically over the next few videos. So let's take a look here. A actual inverse function. Well, on the left-hand side, imagine that it's our original function f of x. The domain has x values. The range has our y values in here. So what makes an inverse function? Well, the range of the original becomes the domain of the inverse, and the domain of the original becomes the range of the inverse. One more time. The domain of the original becomes the range of the inverse. The range of the original becomes the domain of the inverse itself. All right. So how can we use this? How do we utilize it? What can we actually do with it specifically? Well, let's think about as we continue to go deeper into the true definition of an inverse function. It's very, very important, especially as we get closer and closer into our talks on calculus. So let's say, for instance, we have a composition. Let f and g be two functions. We have a composition f of g of x, and we know that x is for every x in the domain of g. All right? And let's say we switch the composition. G of f of x equals x for every x in the domain of f now. And that's what we said was true, right? The domain had to be a part of the original function for it to be a part of the composition of the functions. Now, if this actually is true, then g is the inverse function of f, or we can say that g equals f to that -1, or f inverse. That's how we say that. So in a sense like this is what happens, guys. If this is in fact true and g is the inverse function of f, that means if I were to substitute the inverse function into the original function, I should come up with x. And if I were to substitute the original function into the inverse function, I should get my x. Okay? They're the inverses. That should hold true, right? If f of g of x equals x and g of f of x equals x, that shows us that g is in fact the inverse of f, or we call it f to the -1st as f inverse. All right. Continuing to kind of move forward a little bit more so. Let's take a look at some examples. We talked about this domain and range already, so let's take a look at some examples here. So it says informally determining an inverse here. What does it mean to be informal? We're not going to spend a whole lot of time on this. We can kind of use it a little bit to our advantage specifically. So it says which, all right, are going to end up being an inverse function, right? So which is going to be the inverse, or how can we show that it is, in fact, the inverse function? So the original is f of x. Our original function is 5 over x minus 2. How can we show that h of x is the inverse? Well, think about what we just said. If h will be the inverse, what should happen is if I substitute my h into my f, what I should get is the domain of x. So that's what we have to test on out. So let's see is if we substitute h into f, if we do in fact get x as our result. So our goal is to test f of h of x. All right, well, 5 over 5 over x plus 2 minus 2. Well, those 2's are going to cancel. I get 5 over x. And then, hey, remember, this is like 5 over 1 over 5 over x. The 5's will cancel when it's all said and done. And we end up just getting 1 over x. And it's because it's that reciprocal we can swap it on over and it gets flipped. Okay? And so since we did, in fact, get x as our return, it does show and it does prove that h was the inverse of f in this particular example. All right, let's continue to push forward a little bit. What about graphs? Let's take a look here at some specific graphs of our function. So here are just some basic graphs. The graph of an inverse function will reflect over the line y equals x. So here's some examples here. Our line y equals x is our dotted line in this first example right on here. And we see the reflection over y equals x. Same thing on over here. Our green line in this example is going to end up being our y equals x. And we see that reflection, or the distance from every point on blue, is the same equidistant from every point on red to the line of reflection. And you continue to see that as you look through these four examples. So that's how we can identify graphically if there is a reflection over the line y equals x. All right. Well, there's more to it though. We have functions that hopefully we've heard about in the past. One function is super important. One-to-one. A one-to-one function. A function is considered one-to-one if each value of the dependent variable x corresponds to exactly one value of the independent variable y. A function has an inverse function if and only if the function is one-to-one. So it's super important. So if I substitute an x value on in, there is no way I can get the same y value for two different x values in there. All right. So how do we test graphically if a function is one-to-one? Well, ladies and gentlemen, we do what's called the horizontal line test. If a function has an inverse function if and only if no horizontal lines intersect the graph at more than one point. This is what shows a one-to-one function. So let's take a look first and foremost at a pretty simple example here in which we are using our horizontal line test of x cubed minus 1 and x squared minus 1. So let's take a look. Let's just do a quick sketch, nothing too crazy. Let's think about what x cubed minus 1 is going to end up giving us. So we're going to have a shift down of 1, so we're going to be roughly in this particular area. Let me change colors for our horizontal line test, and I make all these horizontal lines, and every horizontal line that I make, I only go through the graph one time. So yes, we would consider this a one-to-one function in this example. Well, what about a x squared minus 1 graph? Well, let's erase this, and let's think about what a parabola is going to show. Well, you know a little more common sense when it comes down to a parabola specifically. Our parabola in this is x squared minus 1. So once again, we're going to have a shift down a little bit here. But as we make this cuts on through, every time we cut through, we hit it twice. So this is not passing the horizontal line test. So no, not one-to-one, but more specifically, has inverse? No. Inverse. All right? So pretty important as to where they all stem from here. All right, guys, so that's going to wrap up the video for our talk about graphing and one-to-one functions. In our next video, we're going to start diving on into how to find an inverse function algebraically. And we're on to the next one.